Hello, everyone. Let us give a warm welcome to Mr. Jeremiah, who is going to speak on Introduction to Introspection.
Good afternoon. Thank you everyone for coming out to this final talk of a very long PyCon day. I am Jeremiah Paige, and today we're going to get a little intro to introspection. So quickly, if you don't know, introspection is basically the ability for code to look at itself. So we're going to take a little journey today to see how we can maybe figure out what the interpreter sees when it's running our code ourselves and have access to that same information. Python's not new to introspection. It's always had strong capabilities for this. Currently there's about 70 built-in functions, and today we're going to use 15 of them just to look at code and decide, pull out information from it. Some of this information is hidden, some of it's magic, but none of it's meant to be secret. Python's not trying to keep it away from you. It's just trying to keep it out of your way as you code. So where do we start if we want to know something more about one of our objects? Well, we could start, especially from the interactive shell, with a simple call to help. We can just say help, and it'll tell us help's a function, so we can call it for more help. And we can even call for help about help, and we'll learn more about help than we'd ever want to know. But if we wanted to learn about something maybe a little more interesting, we could maybe just hit that tab key on our interactive shell and find this weird name, Pickle. What's up with Pickle? If we ask for help, help will tell us a lot, pages and pages. It'll fill our terminal and scroll off more than I can fit on several slides. Everything we could ever want to know of how to use the Pickle module as we're running Python. But if we break it down, it's pretty straightforward. It starts by telling us about the object we actually passed to help. What is Pickle? It's a module. Its name is Pickle, which seems pretty obvious, but it gets this right even if you use an alias. And it has a docstring, which should help us in implementing, making use of this module. Once we get past the opening, help is going to detail all the classes defined in the module. It's going to give a quick hierarchy of how they relate to each other in inheritance and to other objects in Python. And then for each one of these classes, help is going to list them with their full definition, every method that's attached to them, whether directly or through inheritance. It's going to tell us which ones are static, which ones are class methods, which ones are instance methods. It knows all of this. And once it's done going through all the classes, help is then going to show us all the top-level functions in the module. Again, it's going to show us the name of the functions and the signature, so we know how to call them, and it's going to give us the docstring. Once it gets through with the functions, there's a few more bits of, there's a few other names at the top of the Pickle module that aren't either classes or functions. So for each of these, it's going to show us their names and their values. So these are, in Pickle, a series of constants that it uses for the serialization. And at the very end is the file, which tells you where did this code actually come out of. So that's all very helpful information. When we quit help, it returns us to the interactive shell, and we're back where we were with our code. So we'll try and capture that information and use it to make some intelligent decisions in our program. Except help doesn't return anything. It doesn't leave anything on the screen. When you're done with help, there's nothing left that your program can find and make any sort of decisions about. All that very valuable information went into our eyeballs, but unless we're going to copy it or memorize it, it's of no use to the program. So we're going to need to go and find this information somewhere else. We're going to go exploring the object model in Python a little bit and find some of the Python, or some of the magic that's in there. Before we go and find the magic, a little definition of what magic is. Magic in Python is a common way to refer to special methods, which are also called dunders, which is any name in the language that both starts and ends with a double underscore. If any name both starts and ends with a double underscore, it's reserved by the interpreter, even if it's not being used right now. It's where the interpreter puts all the data it needs to run your program and keep it out of your way as you're doing your normal job. But because it's the only place the interpreter has to put its own information, it's a great place to look for more information about running code. So if we're not going to use the built-in help, is there something else we could use? Well, there's another built-in function that we've probably all used to debug a program, which is you can just print the thing. Print can take any random object and throw you a representation of it. And this works because string actually calls a built-in stir function on all its arguments, which in turn calls our first magic method, dunderStir. So for any objects you want to print, that object is actually asked to execute its dunderStir method to give back a string, and that's what's displayed to the screen. So we can print a module, Pickle, and it'll tell us its type, its name, and its file location, just like help is able to do. But since we're on the interactive shell, we could just print the name, type the name instead. Same data comes out. This is not because the REPL or the interactive shell prints this object. It actually uses a different built-in function called repr. Repr looks the same on the surface. It takes a random object and returns a string to display for it, but it has a different mirroring magic method, dunderRepr. In many cases, it defaults to the same string, but it can be different than what stir puts out. And so if you're typing a program on the interactive shell and you're just typing names, and then you go and make a program that just prints the same names, you can get very different output on your terminal. And since both repr and stir can be overridden by magic methods, this information that we want, this type and name, aren't completely dependable. So we're going to have to go even deeper into the object model and go to the source of where did help know where these things were and where did string know where they were when it used them. So if we go back to the help output, all this information that help told us about Pickle exists in the object. We just have to go find it. So we're going to look at some dunder attributes and recreate this entire text output. So the type, help knew that this was a module without us telling it. It's stored in the object's dunder class. The name, the canonical name was defined with, is in dunder name. Its doc string is stored in dunder doc, and the file it was created by lives in dunder file. This is part of the object model. After help was done with the actual object we passed it, it then showed us all the classes. So for any class we want help on, we can find the same information inside the class object. Its type is in dunder class, its name is in dunder name, its doc string is in dunder doc. Now, classes don't have files because they belong to modules. So there's no dunder file, but there's a dunder module. If we were to go look up that module, it would have a dunder file, and so on. And then the unique thing to classes is that they have inheritance, which modules don't. So we can find the direct parentage of this class through dunder bases. And the method resolution order is also in the MRO. It's not shown by help because it thinks for a class this simple, it's not very interesting. After it was done with all the classes, it then showed us all the functions. There's some repetition here. The type is in dunder class, the name is in dunder name, the doc string is in dunder doc, and again, functions belong to modules. At this point, there's only one thing that's unique to a function, which is its signature. How do we actually know how to call this thing at runtime? At this point, you might think there's a dunder signature, and we're done. We finished recreating help. But in this case, it's much more complex. Python needs to dispatch calls to your function many, many times during execution, maybe millions of times. It wants to be very efficient about this, and the way we write this code is not very parsable on a machine. So we're going to have to dig a little extra deep to recreate this. A function, if it's not function call, if it's not empty, has parameters, and those parameters have names. So that is found in the dunder code attribute, which is the object representing your code compiled for the interpreter. And inside there's a lot of stuff, but there's one attribute called Covar Names. This stores all the names of the attributes for your function call. It's actually pretty complex. It tells you which ones are positional only, which ones can be passed by position or keyword argument, which ones can only be passed by keyword argument. But essentially, it's all there if we go and look for it. After we know how many variables the function accepts, we want to know which, if any of them, have defaults and what those default values are. So for that, we'll go back to the loads object and look in its Dunder defaults. Except for this function, we're going to look in a Dunder keywords defaults. There's 2 locations, and you're going to have to look in both. And finally, some of you might have noticed we're no longer looking at help for the Pickle module. We're looking at help for Tomolib. It's because this function has something nothing in the Pickle library does, which are annotations. This function has a return annotation and type annotations. We can pull those out of the object's Dunder annotations. So with this, we were able to get back all the information help had, but in a way we can actually store in variables. But that was kind of a lot of rummaging through the object model and having to go pretty deep. And maybe it looks kind of ugly. Maybe you're hoping there was a better way. Well, because this is Python, there's not only a better way, but it exists in the standard library. The inspect module is a module designed to inspect running code. Rather than trying to access any of these magic attributes on objects you're holding, you can just pass the object to a corresponding inspect function. And they're much safer. They work on more types. You don't have to do any kind of special casing, and they cover many more cases. Each one of these functions that can take an object is really a question we're asking of something we're holding on to. We want to ask an object, what is your doc string, to maybe find more documentation about it. Or what file were you defined in, which if we ask it through inspect, will be able to tell us for any kind of object, not just modules. But some questions are a little nonsense. We can't ask the number 1 what its signature is. It doesn't have a signature, and it's never going to have a signature. So some of these questions are a little unsafe, and they'll raise exceptions, even using the inspect module. So we know how to ask the questions, but maybe rather than just wrapping all of these questions in some very broad try excepts, we could be a little more specific of when we ask them. We could do that if we knew what the heck the object was before we started asking questions. So only functions are going to have signatures, but integers aren't. And maybe we want to know where a file or a module came from, but maybe we don't care for some string. So there's some built-in functions to help with this. There's the type, very basic. You pass an object and it tells you the type. But unlike all the other questions we've been asking of our objects so far, type is a question you will always get an answer to in Python. Not something you can save many objects in a dynamic language, but because Python's an object-oriented language and everything's an object, everything has a type. So if you ask what the type of Pickle is, it says it's the class module, because everything is an object under the covers in Python. Even modules are just classes, a little dressed up. There's only one other question that's always safe to ask of anything in Python and expect an answer, and that's what is your ID? Not nearly as interesting as what is your type, but you will always get a unique answer per object. Everything else is kind of up for grabs if it actually exists on the object. Another great built-in function is callable. So things that are callable have a signature, and we probably want to call them before investigating them further. If they're not callable, then they're probably a value that we should start poking at right now. But what things are callable? Type could tell us this if we really wanted to go through the trouble of it, but there's more than one thing that's callable. Not just functions, but classes and instances of classes under certain circumstances. And generators are callable, but not everything is. So this is just a quick answer to know whether you should go looking for a signature or not. And there's also the isInstance and isSubclass built-ins to know if something you're holding has a class in its inheritance tree. These are overridable by magic methods in much the same way that print and repr were. Now, you might wonder why Python allows classes to override their definition of inheritance at runtime, why Python just doesn't reach into the definition of the class. There's a very useful implementation of this in the standard library, The abstract base classes module, or the ABC, is a collection of classes that represent interfaces expected across different parts of Python. So there's the iterable protocol for things that can be looped over, the sequence protocol for things that can be walked and indexed by number. There's the mapping protocol, which are things that can give you values based on keys rather than attributes. And Python has concrete implementations of each of these types. There's lists and ranges and dicts, but you can make your own, and they work perfectly well in just about any Python code without having to inherit from a list or a dict. You just have to have the right shape of a class. So if you ask, is instance list, you'll know whether its subclass is list or not, but you won't necessarily know if it's indexable. But if you ask the abstract base class, sequence, is this thing like a sequence, it will say, yeah, that thing quacks like a list, even if it doesn't inherit from list or the ABC sequence. So it'll give you the right answer. You know that this thing can be used for looping or for key access. So with that, we know when to ask our questions, and we know how to ask our questions. We've pretty much recreated all that help could do for us, except for one thing, which is that when we asked help about the Pickle module, help told us about Pickle, what its docstring was, what file it came out of, but also went through and told us every class that was defined under Pickle. And for every class, it told us every method that was defined on that class, even though we had no idea what any of those names were. So how did help even know what the heck it was calling for help? In our original example, we just typed out help, and we hit tab because we were in the active shell, and we got this weird name, Pickle, so we tried it. But in a running program, you can't just hit tab to get some new variable names. So there's going to be some more built-in functions to help with this. First up, Vars is going to return a mapping of names to values for the object you pass it. So you pass it an object, it tells you the names that are attributes and what their values are currently. If you pass no arguments, you get the same for the local scope. Vars actually provides access to the magic attribute dict, which is a private dictionary that actually is what supports attribute access on objects in Python. So Vars is very literal. You ask it what are the variables for this object, and it tells you, but it doesn't try to tell you anything that would resolve for a .name lookup. So Python won't just stop at looking in the dict of an object when you're trying to do attribute access. If it doesn't find it there, it might go looking elsewhere. If it's not in locals, maybe it'll try the outer scope. If it's not there, maybe it'll try globals. If it's not in this class, maybe it'll try the parents, and that could work. Vars won't do that. It's very literal, and it just tells you the objects that, the names that would definitely resolve for a certain object. Some helpers for Vars, there's also locals and globals, which provide the same thing, a dictionary mapping for either the local scope or the global scope. But if these aren't enough, there's dir. Dir tries to be very helpful. Instead of returning a mapping, it's returning just a list of names, but it does its very best to walk the inheritance tree of a class, to look in the class of an instance for you, and find all the names that would resolve if you actually try to go and find them. And it's supported by a magic method under dir. So it doesn't get everything. It's really hard to get everything in a dynamic language, but it tries really hard and it gets there most of the time. And our favorite new standard library module, Inspect, also has a solution to this problem. If you pass an object to Git members, it will kind of do the best of both worlds. It will return you names and their current values, both for the current object and for other names that would resolve, for instance, through inheritance. But it's not a built-in, and also it doesn't work with no arguments, so it doesn't work on locals or global scope. Two more built-in functions, hasAdder, GetAdder. These are no use if you don't know what you're asking about, because you have to pass the name you're checking. But they're the most precise because they go through all the same steps that a dot attribute access goes through. if you ask the question, does this exist on this object, you will get the real definitive answer. So I hope that you realize that Python's not really trying to keep anything secret from you. The only reason these magic methods are hidden is to stay out of your way and so that you don't accidentally use them in your day-to-day programming. There's no real risk in looking at them. If you're really afraid, just when you're in the interactive interpreter, not a mission-critical application, just look at it. There's no harm. You can even change it. You're not going to bring down your computer. You're not going to kill Python. And I hope you go out of here and are not afraid to ask questions of your objects. Thanks you all for coming.
Thanks a lot for the great presentation.
Thank you.
Any questions?
Yes. C1.
What would be the use case of overriding the magic method for inheritance that you showed?
The GetAdder and GetAdder, or sorry, the is instance and is subclass. So right, the question was why would you want override is subclass and is instance, and I was trying to answer that with the ABC subclass, the ABC module. So in the ABC module there is several classes, but one of them is, for instance, sequence, and sequence when is asked if it is a superclass or a super instance of an object, doesn't look in the inheritance tree. It looks for certain methods that would be used by protocols in Python on the specific object. So for sequence, it doesn't look if list is in the inheritance tree. It goes and checks if dunder index, which is the special magic method that is called when you use square brackets, is implemented for that class, because that's all that's required for indexing, and a few others. But so it looks for inheritance through ways other than the bases, which we saw at the very beginning. Any other questions? Okay. Well, thank you all for coming out and enjoy your night.
Thank you very much.